Dear students, today we are going to study about the indexing and hashing in DBMS. Okay, so we have already on that day we have already studied about the indexing. So indexing is used to optimize the performance of the DBMS. It minimizes the number of disk access. Okay, so the index is a type of data structure. So it is used to locate and access the data in the DBMS database table very quickly. The structure of indexes, it has a search key as well as the data reference. This we call it as the index. It works just like the book index. Okay, so we can easily search the data what we want in a book using the book index. The same thing, it is very much helpful in searching a record. So the first column is the search key that contains the copy of the primary key, okay, or candidate key of the data. The value of the primary key is stored and it is sorted order. Okay, so that the corresponding data can be accessed very easily. So what is meant by the second column has the data reference, that it has pointers, a set of pointers holding the address of the disk. Okay, disk block. It has the set of pointers that holds the address of the disk block. So this is the thing about the indexing. So there are different types of indexing methods. So first is the ordered indexes, primary index, cluster index, secondary index. So this primary index, it is classified into dense index, sparse index, etc. Okay, so what is ordered index we can see. So it is usually sorted to make searching very faster. So index which are sorted are called as the ordered index. Indexes which are sorted, this is called as the ordered index. So for example, suppose we have an employee table with thousands of records. Okay, employee table, and each of which is 10 bytes long. So if their ID starts with what, 1, 2, 3, that employee ID starts with 1, 2, 3, and so on. So if you want to search the employee ID with 543, then without indexing the database, without indexing, what it will do, it will search from the first till the 543 records. Okay, till 543 records, and the database will read the record after reading this 543 into 10 bytes long. So for 5,430 bytes long it searches. So in the case of using index, what is the case of using index? Each and every index refer a block of record. For example, if a block of record has two record. Okay, so the searching this index will read like this: 542 into 2, that is 1084 bytes, which are very less compared to the previous case. So indexing is very, very useful in searching a record. So there are we already studied about the ordered indexes. Now we are going to study about the primary indexes. So if an index is created based on the primary key of a table, then that index is called as the primary indexing. Okay. So this primary index are unique. Okay, you're unique to each and every record. So it contains 1:1 relationship between the records. So the primary key, after restoring, it is sorted in an order so that the performance of the searching can be very efficient. So the primary index is of two types, that is dense index and sparse index. Okay. So what is dense index we can see. So primary index has two indexes, dense and sparse. In the case of dense index, what is happening? The case of dense index. So in the case of dense index, it contains the index record for each and every search value. Okay, search key value in the data file. So each and everything has its see, the number of record in the index table is same as the number of record in the main table. The number of index table is same. It has what number of index we are having, the same number of main table records in the main table is there. Okay, so it makes the searching very fast. Okay, so what is the disadvantage of this dense index? It requires more space for storing the index records itself. Okay, so the index record I have the search key, and so index record, what are the things it is having? Search key as well as the pointers. Pointing we already studied here. Okay, so it has set of pointers which points to the corresponding record on the disk. The next we can study about the parse index. What is parse index? So here we are using only few index record. In parse index, we are using only few index record to the data file. Okay, each item pointed to a block. Okay, block of data. Each block has a set of records. Likewise, it is splitted. Okay, so parse index means what? It stores. It requires only less amount of index record. The pointer denotes the particular block. Okay, block has set of records. It needs only less space, less maintenance, etc. for this, for locating a record. So these are the two types which comes under primary index. So what is dense index? Then what is parse index? Now you get a clear idea. Next, what is the clustering index? What is a clustering index? We can see. Clustering index, it comes under the ordered data file. Okay, so we already studied about the ordered. Okay, data file indexing is sorted. Okay, ordered data file. So sometimes the index is created using, sometimes index will be created using non-primary key. At that time, it does not have a unique for that record. Okay, it does not have a unique thing. No, primary key means it is a unique record. A table, if it is a primary key, it has a unique value. Okay, if it is no, if an index is created in non-primary key, then it does not have that uniqueness. So in that case, what we will be doing, we'll be grouping 2 or more columns to get the unique value and create an index out of them. Okay, yeah, 2 or 3 columns are combined together or grouped together to get a unique value. From that, we are creating an index value out of them. This is called as clustering index. So the record will have similar characteristics or also can be grouped. Records with similar characteristics also can be grouped. Okay, so this is the example for this clustering. See, for example, a company have multiple employees, but it has various departments. So the employees are clustered or grouped based on their department ID. So this is given here. So the department ID 1. Here, many number of employees working here. They are grouped into a cluster. So record 1, they are grouped into a cluster. Likewise, for department ID 2, there are many employees working here. So that employee records are grouped into a cluster. So this is the example this is the concept of this cluster index. Next, we can go for the secondary index. So in this parse index, there are many disadvantages. Okay, parse index, so what it will do? So we have already studied the dense and parse. So parse, So parse indexing, the size of the table grows as well as when the size of the table grows, the size of the mapping also grows. So these mapping are usually kept in the primary memory so that the address fetch should be faster. Then the secondary memory searches the actual data based on the address to get got from the mapping. Okay, if the mapping size grows, then the fetching the address itself becomes very slower. Okay, so in order to overcome this problem, we are going for secondary index. So secondary index, what it will do, it will reduce the size of the mapping. What is the advantage of secondary index? It reduces the mapping size. So what it will do, it selects a particular huge, in this method, huge range of columns is there. It is selected and they are kept, dividing the mapping as first level, second level, likewise. Okay. So if the size of the mapping is huge, it is kept in the first level. Okay. Then see, first level means in the primary memory, it is first level is stored in the primary memory so that the address fetched is faster. The primary of the secondary level, it is the mapping of the second level, it is stored in the secondary memory. Second level or actual data. So second level is the actual data. It is stored in the secondary memory. Likewise, it is splitting and storing the thing so that we can reduce the size of the mapping. See, for example, here we are having in the primary, we are having the index as well as the pointers. Okay. So these are the index values, 100, 200, 300. These are the index values. So we want to search a record 111. Okay, we want to search a record 111. So in the second level mapping, it searches the data in the hard disk. So it goes to the 100. Okay. Okay, so 100 record block is 110. Next block is 100.